two tectonic plates converge, it means that they're actually moving in the same direction. Okay? We see examples of this along the western coast of North America and South America, especially along the South American coast, where we see one of the plates actually submerging itself because of the fact that they're crashing into one another. Which one of these things do you think is heavier? The ocean plate or the land plate? The land plate is bigger. It's heavier. The ocean plate is lighter. It's thinner. Okay? Now, don't kid yourself. Both of these things are ridiculously large, right? But because one of them is so much bigger than the other, it causes the smaller of the two plates. It's almost like they're playing chicken. They're coming at one another, and at the very last minute, one of them is going to duck out of the way. Okay? And it's usually the lighter one. So what ends up happening here is the ocean plate ends up losing in that battle of wills, let's say, and it causes the ocean plate to actually get pushed underneath the actual land plate. Okay, so if this is our ocean plate, it causes it to subduct or go underneath the actual big land plate. Now, the cool thing about this is that underneath the ground here, okay, underneath the ground, you've got super, super hot magma, right? All this is mantle, right? All this is mantle. It's melted rock. Yes? So what do you think happens to the actual basically subducted zone here? What do you think happens to this area of rock right here as it gets basically pushed into molten, melted rock? What happens to it? It will then melt too. So it's going to make more magma. This stuff right here is going to start to melt. And it's going to start to melt and melt and melt. So what ends up happening is the fact that you have more magma builds the pressure underneath the landmass. And as the rock that's above the landmass here, the land plate, it starts to crack. Okay? And in those cracks, what do you think starts to get pushed up? Magma starts to actually make its way from down here up through these fissures. And it's going to want to go from an area where there's lots to an area where there's little. That's just natural movement of particles. Particles naturally want to go where there's lots, from where there's lots of them to where there's a little bit of them. Okay? So as this happens, this magma causes more and more fissures until it actually reaches the surface of the actual land. And what do you think happens to it there? If there's lots of pressure here and little pressure here, where do you think the pressure is going to want to go?
It's going to want to come out.
It's going to want to go to where there's little pressure. And this is what causes volcanic eruptions. Okay, so if we actually look at a map of North and South America, especially South America, all of the mountains known as the Andes that border the coast of South America are volcanic mountains. A lot of the mountain ranges that border North America's west coast, so the Rockies, the Cascades, all of those have actual active or dormant volcanoes inside them. Okay, the last one to erupt in North America was Mount St. Helens in 1980 or in the early 80s. Okay, and that's in Washington State. all right, and just south of British Columbia. So this is what happens when we have an actual subduction zone, where we've got water, okay, or an ocean plate coming into contact with a land plate. When we have two much thicker land plates coming into contact with one another, right? So these are two huge land plates, and they're also converging, which means going this way, coming this way, so they're gonna hit. One of them is not lighter in this case. So we don't have the idea of that subduction zone here, okay? One of them's not gonna slide underneath the other one. They're literally gonna crash into one another. And when they actually crash into one another, okay, so if I've got an actual mountain here, if I've got a smaller plate hitting another plate, this one is impacting this guy, depending on what kind of rock makes up those plates. The one with the weakest type rock, okay, and the one that's doing less of the moving is actually going to get bent out of shape. So that actually gives rise to one plate moving forward, like so, crashing into the second plate and actually causing this plate to bend, right? Like this. It basically causes it to get wrinkled. And because there's magma underneath all of this, the magma actually comes in here, okay, and it fills up these holes, but because there's no fissures here, that magma cools over time, and it just creates rock, solid rock. A really good example of a landmass coming into contact with another landmass like that is when the Indian plate crashed into the Asian plate, and it forced the Asian plate to buckle. Okay, so it forced it to basically crumple and bend. It's almost like watching a head-on car collision. When they have those test dummies in the cars and they're testing airbags and things like that, they will put test dummies in a car and they will launch that car at a brick or concrete wall. Well, which one do you think is actually stronger material, the concrete wall or the actual car? The wall. So the wall doesn't really alter its shape, but the car looks like an accordion after a while. Okay, so the same thing happens when two land masses actually converge with one another. One of them's going to buckle and it's going to cause, now sometimes both of them can actually buckle. Okay, so we can see a mountain range or a cluster of mountains form where the actual contact occurred. It ends up being a little bit different when we have two plates diverging from one another, which means they're moving away from one another. So if we have two plates here, there's one, and here's your second plate, and they're nice and close together, right? But they're actually moving away from one another. So underneath here, we've still got our magma, and magma likes to be contained in, below the actual Earth's crust. Magma doesn't like to actually be outside of it because it cools it down. As soon as it's outside of the crust, it cools down rather rapidly. Okay, so it doesn't want to do that. So when these two plates actually diverge, when they split apart a little bit, it's like picking a scab off of an injury. So what ends up happening here is these two guys actually fuse together and we get a little bit of a crust here that forms. Okay, and when they actually split apart, more magma comes out here and just basically patches the area up, right? After a while, that area hardens, okay, like that. And then after a while, they're still separating. More magma comes up, and will actually patch the scab. It will harden after a while. More magma will come up. Do you see the actual trend here? And then this crusts over. Do you see that? So a really good example of this is seen between the European plate and the North American plate. The North American plate's boundary is actually midway through the Atlantic Ocean. And these two plates are continuously separating. So where the actual magma is built up like this over time, we actually see land masses that are so built up from the bottom of the ocean that they breach the surface. A really good example of that is Iceland. Iceland is a landmass that's there because it goes right along that mid-Atlantic divergence zone, that fissure. Okay, a fissure is a split, right? So it creates this trench where it basically creates this big deep rut in the middle of the ocean. Okay, so that's why we say that the Atlantic Ocean is actually getting slightly wider as the years go by. Whereas the Pacific Ocean is actually subducting like this, so it's getting a little bit smaller. So we have proof that this whole idea of continental drift is still happening today. All right? If I have one plate here and another plate here, and they're happy as clams, okay? They're not buckling, they're not crashing into one another, they're not moving away from one another. What these guys are actually doing is they're moving along one another. So what that actually means is this guy might be pushed upwards when this guy is pushed downwards. The space here doesn't change. Okay? So when we have this slipping along one another, this is what actually gives rise to earthquakes. Okay? And what ends up happening is energy will build up and build up and build up and build up, and then all of a sudden it becomes too much and it lets go. And what it does is it actually causes this movement to actually go back and forth, okay? And that's where you get a rumbling of the ground until that pent-up energy is released and the ground is calm again, okay? A really good example might be if you're taking drops of water and you're dropping them onto a surface. Okay, that water forms a nice little dome, right? Those little water drops, but at some point, too much water is added, and your nice little dome of water here splatters and it goes somewhere else. It spreads out, right? Because it can't be contained anymore. There's too much potential energy there, okay? The same sort of thing happens with earthquakes, and we often see that earthquakes happen, or very strong earthquakes happen along the borders of tectonic plates. Okay, most recently, a pretty heavy earthquake happened in Italy. If you look at a map of tectonic plates, Italy borders is basically the underside of the European plate. It's where the European plate and the African plate actually converge. Okay, Greece can sometimes have pretty powerful earthquakes. All right, this winter. Okay, one of the major earthquakes, in terms of loss of life and property damage and what have you, happened when, I don't even think you guys were born yet. In 2004, all right, along the actual Indonesian plate, a huge earthquake happened underneath the ocean. What do you think happens to all the water on top of that crust that rumbles? It gets all scrambly, and what do you think that causes? Tsunamis. Because that energy has to go somewhere. So when we talk about the three types of plate movement, okay, we've got plates coming together. There's two examples. We've got plates coming apart, and we've got plates sliding along one another.